let us define position precisely. First thing that we realize is I need what we call an origin. Okay, so we are going to use this idea and we'll call this origin. Okay, now if this is the origin, now there are many points on this line and we are right now going to only study motion in a straight line. But then so many things move in so many different ways. This guy is not moving in a straight line. We'll study all that next. Okay, the easiest motion is motion in a straight line. So we'll start with this. Because we are not trying to see motion. We are not trying to just say, I saw it go up and rotate. No, that's easy to say. You want to say how it rotated. You want to actually be able to describe it very, very precisely. Now that is quite complex, and to do that, let's start with the easiest version. Now, if I look at this, then I take a scale and measure off, and suppose I call this 1 meter away. We usually call this point 1. Now this is a name. What's your name? Kaushik. Kaushik. So if I say Kaushik, it refers to this guy. Is there any other Kaushik? Right now, maybe not. Okay, not in this class. But if I had two Kaushiks, then I said Kaushik, it becomes a problem. So you say, okay, Kaushik 1, Kaushik 2. Okay. Now I just point here and say Kaushik 1. Basically, if I just say Kaushik here or Kaushik there may be two of them. Right? It becomes reasonably clear from context. But in physics, that's not good enough. So when I say 1, no other point should be 1. But no other point is 1. What about this guy? 2. Now somebody can say, wait a minute. What if I go that side? That is also 1. Don't call it 1. Call it something else. And you already know that this is called minus 1, minus 2, minus 3, minus 4, and so on. And here I have 3, 4, 5, and so on. We call this the number line, or in physics we use a little bit more. We call this the axis. So what do we call this usually? X-axis. Now suppose you say, wait. What about this point? You say, not with this line. So what do? We put one more axis here and then we'll call that the y-axis. So then this point will be x is 1, y is maybe 2 or 1.5 or something. But right now we won't study it. But you know that if you can explain everything in terms of the x-axis, then we can always extend it to the y-axis. So is that clear? Okay. Now remember, the origin is important. Why is it important? Because it tells you where are you counting? Where are you? What is this point? It is called 3 because it's 3 from the origin, 3 meters from the origin. Now this is a great way of naming points, because if I say I am at A, you don't know where is A. But once you know the origin, if I tell you I am at minus 1.3, do you know where you are? Could I be here? Could I be here? Near 1, minus 1? No. What about there? No. So where am I? So am I here near that minus 2? No, you even know this much. You know that it can't be that side. It has to be on this side of the half line. So this is where you are. So you know exactly where you are when you say you are at minus 1.3 meters. So I will ignore the meters. I'll just talk about this. So this tells you every point name. So that's why we use the x-axis to talk about position. Now, if you look at this whole thing, there is a positive direction and there is a negative direction. So we call this the positive x-axis direction, or just the positive direction. So if I move in this direction, which direction am I moving in? Positive. And if I am moving in that direction? Negative. So this automatically becomes the negative direction. Now I am not saying that that has to be negative, because if I just took the number line like this and decided this is the origin, this is 1, this is 2, this is 3, what am I choosing the positive direction to be? That way. And then this will become minus 1, minus 2, minus 3. I have the right to choose positive this way or that way. Okay. But if I don't say anything, usually what are we going to assume as positive? This. Because that's just convention. So suppose somebody says, let us move in the positive direction. But they didn't tell you which direction is positive. Which way did they mean? That way. But if they say, wait, I am choosing the positive to be that. I am moving in the negative direction. Which way did I move? Down. Because once I say which direction I am moving in or which direction is positive, that defines it for the question. But if I don't say anything, usually we'll take that to be the positive direction. Okay?
You say that positive is up without giving the origin, it doesn't work.
No. Okay. Very good point. Very good question. So you understood his question? His question is, does the origin decide what is positive, what is negative? Does it even matter? Actually, it does not. The positive negative direction is independently selectable. Origin is independently selectable. For example, suppose I say I am moving in a straight line like this. Now that could be plus, this could be plus. Now suppose I say this is plus. It's fixed. This is minus. Now I can after this select this to be the origin or that to be the origin or that to be the origin. So if I say this is my origin, now everything here will be plus and everything there will be minus. Now origin selection is an independent point and plus minus direction is independent. These are two different things that we are doing, but when you put both together you get the x-axis with all the points marked on it. Yes?
But sir, what if the origin in this case is under that line? Say it's somewhere else, totally different.
Here.
Say the same origin is like, say instead of using that origin, suddenly you change to that origin or something. But like how will you retain the direction? It can be.
Yeah, then you have to have the direction like this. So if this became the origin and you wanted this direction, then obviously the line would have to be like this.
Yeah.
This would be the positive and that would be the negative. Right? So origin choice is a separate choice. Is that important? Origin, is it important? Actually, in certain cases, to talk about position, it is important. Direction, very, very important. You want to know whether you are moving in the positive direction or negative direction. Origin is important, otherwise you won't be able to say which point is what name. Okay, all these are names. Minus 2.3, minus 4, minus 1, plus 2, plus 3. All of these are names for points. Okay, so let us use this a little bit. The more you use this, the more familiar you become with it, the better it is. So we'll just apply it for a few cases and then we'll try and understand this a little more. So let us take this. If I say I am starting here and I walk like this to this place. I started at minus 2 and I went to 3. Okay. Now how do I know I started at minus 2 and went to 3? I just told you. How do I represent this motion? Maybe like this. But if I started at 3 and came to minus 2, how would I represent the motion? Now when we just draw it like this, it look like this line. So not very useful. So we'll put an arrow. We'll put an arrow to say you went like this and you went like that. But also notice something, there is a problem, no? Now this line is getting blocked by the earlier line. So instead of drawing it on this axis itself, so I can draw it like this. Does this mean I am going like that? No, I am still going on the straight line. Except this is more convenient for writing and drawing. So what we are going to do is to say this is how you went. But what if you went like this? Okay, so we'll keep talking about arrows like that, but that does not mean you are actually moving like that. It actually means you are moving like this.
In case you want to move like that, how would you put the arrow?
You have to move like what?
In case you want to move
That doesn't
like
work if it's...
You mean you are going like that and like this. So you will do this and that. You will put both the arrows.
No, like if you're moving like that in a circular motion, how do you?
Oh, okay. Then it won't be in the straight line, no? So her question is interesting. Her question is, what if you actually move like this? Well, if you actually move like this, it won't be motion in a straight line.
But how would you represent it?
How do you represent it? Well, you will do this, and you will have x-axis and y-axis, and you have to say you started at x-axis here, then you went till there, and then you went till there. Now, yes, it is complicated. You will have to figure out a way to draw it well. But this is motion in a straight line. So everything that is moving around, we are going to say is moving on this line. So these arrows are not actually telling you how exactly it moved. This is just to schematically tell us that yeah, it went like this. I'm just telling you that this is not a great mathematical or physics point. It is just a representation to say that you are actually going like that. Don't get confused about the fact that you are going up and coming down. You are actually going like this. But that is not the key point here. The key point is, if I want to know the direction of motion, it is not enough to write this, but also put an arrow. Okay. But if I tell you, I didn't tell you which way I moved. Suppose I just told you, I was at -2. I was at 3. So did I move that way or did I move this way? But how do you know? How do you know?
Specified. You have to specify. It wasn't specified, so you can't.
I was at -2 was specified. I was at 3 was specified. Because when you go from your home to school and you go from your school to home, right? Both places there is school and home. You are at home, you are at school. Did you go from home to school or school to home? Well, you did both. So it's not very obvious unless you say which happened first, which happened next. So it's not enough to just talk about. Remember, the original definition of motion was position changes with time. So I need position and time, both. So it's not good enough to say position is -2. It is also equally important to say time is something. If I tell you, you were at -2, x is equal to -2 at t is equal to 1 p.m. And then if I tell you, x is equal to 3 when t is equal to 2 p.m. Did you move this way or did you move that way? This way. Hopefully it was the same 2 p.m. of the same day. If it was the previous day, then it's cheating. Okay, but we will not cheat. So we'll say this was 1 p.m. After 1 hour, you are there. So clearly you moved that way. Actually, you could have moved like that. You could have gone back and then come here. But let's not assume and complicate things. So let us just simply say that this is how this person is moving. So you need both x and t. But you see, with x it was so simple because we just start by saying -2, -3, 2 meters, 3 meters. But this t has 1 p.m., 1:30 p.m., 1:05 p.m. and so on. That makes it more complicated. So just like we fix a 0 for x. What was this 0? Some random point. I know it's an origin, but you just decide this is the origin. This is the origin, right? You quickly decide that one of the points is origin. The same way we can decide that some particular time is 0 time. So for example, we usually do this with years. When were you born? 2002. So we will say your name is Vijay. So if we say BV and this is before Vijay, and then we can have a AV which is after Vijay. We usually use this with BC and, well, nowadays you say instead of AD you say CE, okay? But basically the idea is before Christ and after, right? So that's the way that we generally split. You can start with before Vijay and after Vijay. So 2002 becomes 0 time. Okay, now if people will say, why should I use his time? I will use mine, right? Now that's okay, but any time can be thought of as the 0 time. After times plus. What about before times? So do minus times exist? Yes, they do exist. They do exist. Absolutely. Okay. Do minus positions exist? Yes, they exist. Okay, same way minus times exist. Suppose I say 1 p.m. is t equals 0. Does that mean that 12 p.m. didn't exist? T equals 0 is 1. So everything only afterwards exists. What about 11 a.m.? Exists. So what will you call 11 a.m.? Minus 2 hours. Okay, this is all. Usually we are going to use seconds, but if in terms of hours you want, then if you want to do 11 a.m., 11 a.m. would be 12, 11, it's minus. So it would be t equals minus 2 hours. And what about 3 p.m.? 1, 2, 3. So therefore t will be plus 2 hours. So can you have negative time? Yes, you can have negative time. Now let us try and understand something here very important. These are markers. This is a marker. What does this mean? This is a marker. It tells you where is this point. It is a name. When you say it's minus 2, that means it is 2 meters from the origin in this direction. What is minus 2 in terms of time? Suppose it was minus 2 seconds. What does it mean? 2 seconds before t equals 0. This is allowed? Absolutely no problem. Just because you were born in 2002, you can't say that nobody existed, universe didn't exist before that. Your time starts at that point. So t equals 0 is when you decide to open your eyes. Okay, he opens his eyes at some particular time, but I was born before that. I existed before that. Your parents existed before that. Your grandfather existed before that, right? So clearly all those times did exist. So do negative times exist? Yes. But when we use time or we use position, usually we use it in two different ways. From 1 o'clock to 4 o'clock, how much time has happened or elapsed? 3 hours. Why can't you say 4 o'clock is 4 hours?
Because it's from 1 to
So
the.
because 1 p.m. is plus 1 to the whole.
So the point is, 1, we are using 1 as a indicator, as a marker. But then there is something else also, which is basically the time interval. So when you're looking at the time interval is 3 hours. Suppose I drop this marker. Did it fall for minus 2 seconds? Is that possible? No, that is not possible. But can I say I dropped it at minus 2 seconds? Yes, because when it fell down, I can say that is 0. So it was dropped 2 seconds before 0. Now the same t equals minus 2 seconds is allowed, but time interval of minus 2 seconds not allowed. Try and understand the difference between the two. Whenever we use time 2 seconds, we can mean two things. We can mean that from t equals 0 it is 2 seconds away, which means it could have been 2 seconds before, 2 seconds after. So this guy is actually saying it is 2 seconds before 0 time. Is that allowed? Yes, it's allowed. This guy is saying between these two things that happened, the time gap was 2 seconds. So whenever you use 2 seconds, you could be talking about time instant or time interval. And are they different ideas? Different or the same? Different. They both use seconds and they can thoroughly confuse people. Okay, physics has many such things which are very confusing because unless we know the difference between them, sometimes it will say no, time, negative time not possible. Of course it's possible. What negative time is possible? Time interval negative is possible? No. Time instant negative is possible? Yes. If you say 1 o'clock is 0, you obviously have 11 o'clock which is minus 2. No problem. But from 11 o'clock to 1 o'clock, the time interval is minus 2 hours. No. That is wrong. That is 2 hours. From If I say from 3 o'clock p.m. to 1 o'clock p.m., what was the time interval? It is still 2 hours. Just because I asked the question in reverse does not mean that the answer is negative. I hope everybody is clear about that. The same way, from this point to that point, distance is 1 meter. From this point to this point, distance is 2 meters. Now from 0 to minus 2, distance is minus 2 or 2? It's still 2. This is still 2 meters. Except you are 2 meters in the negative direction, and so we write this point as minus 2. This point's name is minus 2. The length gap is not negative. So can lengths be negative? No. Can time intervals be negative? No. Can times be negative?
Yes.
Time instants? To be more precise, you should say time instants. Can it be negative? Yes. Can positions be negative?
Yes.
Yes. We will later see that we can also have something called negative, but not distance. We'll call it as different name, which will look like an interval, like a gap, length, except it will also have a sign, and I'm assuming a lot of you already know the name for it. What is it called? Displacement. Then we'll basically say that can be negative, but that is not the length. Okay? So I hope this part is clear. So now we can have a better definition for motion. Motion means I must tell you x1 at t1 and then x2 at t2, and this gives me a description of motion. Okay, so I must know both x and t. If I just tell you only one of them, suppose I say at 4 o'clock this guy was at the gate. Have I told you something?
Yes.
I have told you something. Suppose I say at 4 o'clock. That's it. How much information have I given you? Well, it is always at 4 o'clock something happened, but you didn't tell me what. Suppose I say at the gate. It's only position. Who was at the gate when? Nothing is given. So, unless I tell you position and time together, it is of very little value. This together is one piece. Okay? Yes?
If you just specify the time and the position, it does not make any sense, sir. Only when you specify the surroundings, it tells you how much distance it has moved. Right?
Very good, very good. So his point is just telling you position and time alone may not make much sense.
But surroundings doesn't matter because your position is given.
That's why we talk about x. Because once I tell you x, isn't the surrounding already there? Because first of all, to talk about x is equal to 3, you must have an x-axis. You must have an origin. Surroundings is already given in that sense. So who tells you the surroundings? X-axis is telling you the surroundings. T means already there is a clock. There is already something which is telling you which time and where you were at that time. So these two actually specify a lot of things.